equations. So we basically, like everything else we've done so far in this class, like we learned how to add, subtract, multiply, divide expressions, and then we're going to learn to solve equations containing that type of expression. So when we solve radical equations, a radical equation is just an equation that has a radical in it. You can solve any order radical equation, so the index could be 3, 4, 5, like we talked about yesterday. There's like the third root, the fourth root, the fifth root. We're just going to be solving radical equations that contain a square root, but the same idea can be applied to other types of radical equations, and next semester you'll work a little bit more with the higher order ones. So let's start with like the simplest radical equation I can think of. So let's solve the square root of x equals 3. So first I want to just think about it. Like a lot of these simpler equations, you can kind of just, if you think through what they're saying, you can figure out what the answer is without knowing any tools for actually solving radical equations. So this equation says the square root of some number is 3. So what does that number have to be?
9.
It has to be 9. So we know that 9 is a solution to this equation, because if you take the square root of 9, you get 3. So also notice that 9 is what you get when you square 3. So our general process for solving radical equations is going to be to undo that radical. And we know that if you square something, then take the square root of it, you just get what you started with back, right? So we are going to square both sides of the equation. And I always put both sides in parentheses because it's really tempting sometimes to square each term. In this case, we don't have more than one term, but it can be tempting to square each term as opposed to squaring the entire left and right side, which is what we want to do, like the entire left side to the second power and the entire right side to the second power. And we'll talk more about that when we have more terms to work with. But so the square root of x squared, just, you don't have to write all this, but this is the same as the square root of x times the square root of x, right? Which gives us the square root of x squared. So it doesn't matter if that exponent is under the radical or if it's outside the radical, it's equivalent either way. So you definitely don't have to rewrite it as this, but we know that that's equal to x, right? And so like this radical and exponent kind of just undo each other. They're inverse operations, just like addition, subtraction, multiplication, division. So like when I want to undo addition of 3 on one side of an equation, I subtract 3 from both sides. If I want to undo multiplication by 3 on both sides of an equation, I divide both sides by 3. So here, if I want to undo the square root, I have to square it. That's the inverse operation of the square root is an exponent of 2. And so then, of course, we get x equals 9, which we knew was true. So let's look at one that's similar. So does anybody have anything to say about this before we try to solve it?
Well, you don't want to put parentheses around like -3, right? Because then it would be positive.
Well, you do have to put parentheses, or if you're going to square it, you have to square the entire right side. So we do have to put parentheses around the entire left side and the entire right side. So what we decide to do, we don't get to make the decision based on what we're going to end up with. We have to do mathematically, when we say we square both sides, we can't choose if we want to do this or if we want to do this. Because squaring the right side gives you this, even if it's not what you want it to be.
Then you should never have a negative.
Why not?
Well, I guess if you have a different exponent.
You're actually right that you, but let's get there and you'll see why. So here we get x and here we get 9. Everybody agree so far? So this means if we were to check this, that would mean that I'm going to replace x with 9. So I get the square root of x, or sorry, not the square root of x, the square root of 9 equals -3. Is that a true statement?
No,
It is not. Why not?
because the square root of 9 is +3.
Remember the definition of the radical symbol? Is that it is the principal or positive square root, which means that this side of the equation, no matter what x is, that side of the equation is always positive because that symbol represents a positive number always. I mean, I can put a negative sign in front of the symbol if I want it to represent a negative, but the symbol itself always represents a positive. So this is always positive. Can't make an H apparently. There we go.
So if it was a negative, would we put the absolute value lines around it?
No. So again, we can't do something because we want something to happen.
Okay.
Like, it either is or isn't negative. And based on what equation we have, we can determine if we have solutions or not. But we can't arbitrarily be like, oh, I'm going to take the absolute value because I want it to be positive. Right? So it just is what it is. And this equation, the original equation, says, regardless of what numbers we use, this equation says positive equals negative. Right? Because the left side is always, that square root is always a positive number. And the right side is -3, which is always a negative number. And so this statement can never be true, right? A positive is never going to be equal to a negative. So there is no solution. So this is another place we saw extraneous solutions when we solved rational equations, right? Because sometimes we got solutions that made a denominator 0, and that made it all undefined. And this is another place where you can get extraneous solutions. Just like when I squared both sides of this, I got x equals 9, so presumably that's a solution to the equation. But then I note that it's not actually a solution because that left side of the equation is always positive. And so there's not anything I can plug in for x that's going to make it negative. So what happens here is that when we square both sides, your equation, let me rewrite this. So when we get to that last step, after squaring both sides, your equation doesn't know whether this was a 3 or a -3 because you get 9 either way. And so the possibility exists when you square both sides that you started with something that was never ever true, even though you can square both sides and get what looks like a solution. And so the way we're going to check for that is we're simply going to look at, once we get that radical isolated on one side of the equation, we're going to look at if the other side is positive or negative. Because if it's negative, we can throw the solution out. So there's sort of a couple ways you can approach this. You can either check to make sure that the right side is positive, and if it's negative, just say no solution. So for instance, if you just, there's certain things I can't erase without erasing stuff I want. So back it up. Jeez. Almost there. Okay. So if I gave you this question on a test and all you wrote was no solution, I would be super happy with that. So this is actually a case where like showing less work shows more understanding, because the alternative is that you can solve it, right? Like you can square both sides. Get x equals 9, and then be like, I'm going to check. And then say no solution. So this and this are both perfectly acceptable ways to present the problem or the solution. That first one means you know that that radical has to represent a positive, and so you didn't even bother to try to solve it. I mean, the first one just shows that you really understand what that radical symbol means.
Well, they're going to be more complex problems than probably.
Right? Like, so there's nothing wrong with the second one. It's just you're kind of following a process rather than thinking about what the equation actually is saying to begin with. But either one is fine. Like, you don't, if you know that that square root represents a positive, so it can never be equal to a negative, then you don't have to write anything other than no solution anytime there's a negative on that side. Be a little careful, though, because this is not necessarily a negative number, right? Like the right side, if x was, say, 10 minus 3 is positive, right? So just because there's a minus sign in the right side doesn't necessarily mean it's a negative number. So let's solve a few more, and we'll kind of see how this comes up in each one.
Well, like we were doing, can't you move the negative 3 squared to the left and then come up with a 0?
You could, yeah.
So that would turn that into a positive.
Well, I mean, my point with this is just that whether or not this is positive or negative depends entirely on what x is. And so, like, you would have to solve the equation first and then go back and check. And we'll do several like that so we can see what it really looks like. So let's solve a few of these. In general, our process is going to be, so let's see, whoa. There we go. Solving radical equations. So the first step is going to be to isolate the term containing the radical. On one side of the equation. So what we mean by that is essentially solve the equation for the radical. So if I have, for example, I want to solve the square root of x minus 4 equals 7, for instance. So the term containing the radical is this one right here. And if you were to square both sides at this point, that would be the entire left side squared and the entire right side squared. But remember, that's the square root of x minus 4 times the square root of x. And when you distribute, your middle terms are still going to have the square root of x in them. So squaring both sides doesn't get rid of the radical if there's multiple terms over there. And so we need to always get that radical, or the term containing the radical, by itself first. So in this case, we would do that just by adding 4 to both sides. So we would get the square root of x equals 11. And now so what you're looking for in this step is you just want one term on the left side, or I mean it could be the right side, but you want one term on one side of the equation that contains a radical. It's okay if you have like a coefficient here. When we say term, we just mean no addition or subtraction, because that's where we have to distribute.
The coefficient has no effect on moving stuff to the left or right.
Yeah, the coefficient doesn't negate the fact that when we square both sides, we will undo the radical. So if there's addition or subtraction there, squaring both sides leaves us with a term containing a radical. If there's a coefficient, squaring both sides still gets rid of the radical. So we'll do an example with a coefficient here in a minute, so we can see exactly what it looks like. So then at this point, we can square both sides. Of the equation. And remember, that means the entire left side in parentheses squared and the entire right side in parentheses squared. You cannot square individual terms. So if you had like an x plus 5 on one side, you can't do x squared plus 5 squared. You have to do the entire thing in parentheses. So then the square root of x squared equals 11 squared. Notice that I wrote that as a separate step. I did not write on top of this step. And that's going to be really important when we check for those extraneous solutions, that you don't lose that step right before you square both sides. So if I write on top of that step, notice that there's nothing there that has the radical by itself on one side of the equation, because I wrote on top of it. And so if you write on top of it, you lose this step right here, which is the one that's really important in checking the solution. So checking for those extraneous solutions. So this is going to give me x equals 121. So the third step is to solve the resulting equation. In this case, there isn't a resulting equation because we're just done, but depending on the problem. And then the last step is to check each solution in the step immediately before squaring both sides. And the reason that we check it in that step, so in this case, that's this step right here. The reason we check it in that step is because I have a radical isolated on the left side. So I know that this is positive. So the only thing I have to check is that the right side is also positive. And depending on if I have a variable on the right side, what I got at the end will make a difference. But in this case, this is also positive. And so that's a good solution. As long as both sides are positive. It's not an extraneous solution. But it has to be in that step. It can't be like in this step, because that -4 is going to affect the sign of the right side when we add it or subtract it. So let's do some more. Questions so far? Not too bad so far? Okay.
So far.
So, just wait.
So let's solve.
I feel like as soon as we start adding more into the radical, that it's going to become harder.
Well, so it turns out that adding more inside the radical actually doesn't change anything. But when there's more going on outside the radical, then yes, definitely it gets a little different.
Probably radical.
So let's look. So let's solve the square root of 30 minus x equals 0. So the radical ends like right here. What's the first thing I should do?
Add the x.
Yeah, I'm going to add x to both sides. So notice in that first step, you're only working with things that are not under the radical. So we get the square root of 30 minus x equals x. So now the left side has only one term, and that term is a radical expression. So even though there's addition, subtraction inside the radical, that radical itself is grouping that single term. So now I'm ready to square both sides, which we are not going to write on top of this step. We're going to write a whole new step. I promise you it's not just because I want you to write more. It's because if you lose this step, then in step 4, when you try to check each solution, then you can't because you wrote on top of that step, you lost it. So squared equals x squared. Whoops. That's not what I meant to do. I meant to get rid of this. So on the left side, when I square that, what do I get?
60. No, never mind.
When you square the left side,
When you
have
square that radical,
root 30 minus x times root 30 minus x.
which is equal to what?
60
What's the purpose of squaring both sides? Yeah, it's going to be 30 minus x, right? Remember, the purpose is that the exponent of 2 undoes the radical. So we just end up with 30 minus x. And then what do you get on the right side?
X
X squared is x.
is x squared.
Yeah, it's just x squared, right? There's no radical there. So there's nothing that cancels off that exponent. What type of equation is this?
Linear? No.
It's quadratic, right? It's degree 2.
So then you can factor it.
We can solve by factoring, but first we have to
Put a 0. Well,
get
you
a
have to
0
move
on
the
one
x
side.
too, so that you get a 0, which would make it negative.
Oh, I don't want a negative x squared, so I'm going to move everything else. I'm going to add x to both sides and subtract 30 from both sides. here, I'll just write it in a different order, or in a different place. I started with x squared on the right side,
Right,
and I'm gonna add x to both sides.
right.
That takes care of this. And subtract 30 from both sides. That takes care of that. That gives me
Oh, so
0
you're just
here.
moving it the other way.
Yeah, because I don't want a negative coefficient on my x squared. But we don't really like the 0 on that side, so we'll just put it on that side. So then we're going to factor the left side. So we get x plus 6 times x minus 5 equals 0. We'll set each factor equal to 0. Oops. So x equals negative 6 and x equals 5. So now we're ready to check. So we're going to look at this step. Remember that this side is always positive. Right? Because it's a radical symbol. So if I put x equals negative 6 into that equation, will the right side also be positive? If I put negative 6 in for x?
No,
Well, no,
because if you put
Like,
Yeah,
won't
it
that
won't
just
be
make this?
positive.
for both x's.
but you put it on that side so that you can move back over.
We aren't moving anything.
Oh,
We're
you're
just,
not moving anything?
nope, we're just checking. So
Oh, but
we're,
if you put the 5, now you
okay,
can't.
we're one at a time. If I put negative 6 in for x, will the right side be positive or negative? It will be negative. And a positive cannot be equal to a negative, right? So this is not a valid solution.
I was excited because it was 30.
I mean, you can do this the long way too. You can go 30 minus negative 6 equals negative 6. You get the square root of 36 equals negative 6, which gives you 6 equals negative 6, which isn't true. Right? I'm just kind of saving us some trouble because I know that if the right side, if when I plug my x value in, the right side is negative, that it's never going to work. So then if I plug 5 in for x, is the right side negative or positive?
Positive.
It's positive, right? It's just positive 5. And so this is a valid solution. And so the only solution to this equation is x equals 5. Good stuff?
6 times 5 is 30. That's just cool. Or did it just work out that way?
Well, I mean, it worked out that way because we factored this polynomial.
Yeah, I know,
and
but
so
I just caught that. It seemed cool to me at the time. I forgot we just factored it out anyway. Circles.
okay. Are we ready for another?
Why do you always look at me?
Because you're what we call a nodder and smiler. Like there's always like one student who like you know you feel encouraged by because they seem like they're actually paying attention. So you always look at them.
Of course I am.
They're not like on their phone or falling asleep or anything. Okay. Let's do. Also, I know you'll speak up if it doesn't make any sense. So.
Squeaky wheel gets the grease.
Let's solve.
I said that.
Got it right here among the other stuff that I gotta remember.
We don't want to do that one next.
Wait for that Alzheimer's disease. Then who?
Let's do this one. Let's do x minus 9 equals the square root of x minus 3. Okay, is the term containing the radical by itself? Yes, there is no addition or subtraction outside the radical on the right side. So we're good. So we can square both sides. Remember, that means the entire left side and the entire right side. Okay, when you guys are done with that step, look up. Okay, now you don't have to tell me the answer to this question, but I want you to look at your paper and ask yourself if it looks like that or if it looks like this. If it looks like this, you just got rid of the step you're going to check your answer in. Do you guys see what I'm saying here? So I know I'm belaboring this point, but it's super important. So it should look like this. We should see both of these steps distinctly as separate steps. Okay, so on the left side, I'm squaring x minus 9, which remember is x minus 9 times x minus 9. It's not the same as squaring both x and 9. On the right side, what do I get when I square that?
Just x minus 3.
Yep, just x minus 3. Because the exponent undoes the radical. So then we're going to distribute. So I did something in my head there, right? Like x times negative 9 is negative 9x, and negative 9 times x is negative 9x. So when you add those together, you get negative 18x. So I just did that addition in my head. What type of equation is this? Quadratic, so I'm going to get a 0 on one side. So I will subtract x from both sides, and then I will add 3 to both sides. And then we will factor. This factors into x minus 12 times x minus 7. You will eventually. I've been doing it for a long time.
Did you subtract the x?
Yes. Right, negative 18. If you start at negative 18 and you go down, you go to negative 19.
Right.
Oh, you just.
So then I'm going to set each of these equal to 0. So x equals 12 and x equals 7. So now it's time to check. Remember that the side with the radical on it is positive. So what we're checking is if the left side is positive or negative. So if I put 12 in on the left side, do I get a positive number or a negative number? 12 minus 9 is positive. So this guy is good. If I put a 7 in on the left side, positive or negative?
Still positive.
No.
So look at the left side of the
That's 7
equation.
minus
Oh, the
9.
left side.
Yep. So 7 minus 9 is negative 2, right?
Yeah.
So we're looking at the side that doesn't have the radical on it because we know the radical represents a positive number. And so when we look at the other side, that's what's going to tell us if we have a valid solution or not. And it is true that most of the time one of the solutions works and one doesn't when you get two solutions, but that's not like a steadfast rule. Like, it's possible for both of them to work. It's possible for neither to work. But admittedly, most often one works and one doesn't.
Is it possible to have something you can't factor?
It is. We won't have that until Monday. But once we learn how to solve quadratic equations by other means, then we can start solving ones that don't factor.
I'm
So,
hoping that'd be in the next like class activity.
oh, it's really not that bad.
You know you want to take that 4x4. Amanda would miss you.
I would.
See?
It's too much for me. I can't
You can
think that fast.
I can't either, but you get a little bit of help with a calculator.
Yeah, it doesn't do much other than like,
I figured that.
I mean, like, it's an algebra class, so just like this, like, yeah, like if we had a calculator here, it might help us get that 12 and 7 faster. But I mean, that's really all the calculator would do for us in this problem, right? So it helps
still
you
have to-
do basic calculations, but once you get to algebra and calculus, like, most of the stuff that's challenging about it, the calculator won't do for you. But it does help with, some of the annoying long division and multiplication stuff. Okay. Here's one for you guys to try. Here, right? Remember that x squared is just x squared. There's no square root on that side. So when you square x, you get x squared. The reason you just get 3x here is the thing that we're squaring on the left side isn't 3x. It's the square root of 3x. And so these guys undo each other. But on the right side, there's no radical for that exponent to undo, and so nothing cancels that exponent out. So we just get x squared. And then at this point, there's a temptation to like divide both sides by x, which you cannot do. So you can never divide both sides of an equation by anything that contains a variable, because it will always cause you to lose a solution to your equation. So you'll get one solution that's true, but you'll lose another solution, or at least one solution. So in this case, we see that this is a quadratic equation, and so we're going to subtract 3x from both sides to get 0 on one side. And then we'll factor. So in this case, we factor out an x. And then we'll set each factor equal to 0. So we get 3. So see how if you had divided both sides by x at this point, you would have lost this solution. So it's not that it won't give you a valid answer, it's just, you just lose one of your solutions. So then we're going to check. So we're checking in this step right here. This guy is positive, which is kind of a lie. I mean, when I write positive, I really mean it's non-negative, which seems to be the same thing, but non-negative numbers include 0, whereas positive numbers don't. So it's okay to have 0 over there. You just can't have a negative. So if I put 0 in for x, is the right side negative? No. So this guy's okay. If I put 3 in for x, is the right side negative? right? This is the right side. So if I put 3 in there, the right side is just 3. So this is a valid solution as well. And so both solutions work. Okay, so before I have you start on your homework, I want to do one more example where we have a coefficient on our radical, just so we can see what happens in that case. So let's solve, where'd it go? There you are. Let's solve 2 times the square root of x minus 1 equals x minus 1. So is the term containing the radical by itself?
Yes.
It is, because this is a single term, right? The only thing we have to worry about is if there's addition or subtraction outside the radical. So it's okay to have that coefficient of 2. So we're now going to square the entire left side. And the entire right side. So when we square both, or when we square the left side, remember that when it's multiplication in here, this is the same as just squaring each factor. Right? Remember when we did these guys? That was like a to the third, b to the third. Right? So when there's multiplication in the parentheses, you can apply the exponent to both factors. So in this case, our 2 factors, the things that are being multiplied are 2 and that radical. And so we can square the 2 and square the radical. And then on the right side, this is x minus 1 times x minus 1. So we have to be a little bit careful here. 2 squared is 4, right? There's no square root over that 2, so we actually have to square the 2. And then the square root of x minus 1 squared is going to be x minus 1. Since I got rid of that radical, I got rid of the grouping symbol that was grouping the x minus 1 together, so that's why I put parentheses around it. Just like when you clear fractions, you have to put parentheses around like your numerators, right? So same thing here, that radical groups that x minus 1. And so when we get rid of the radical, we have to do that grouping on our own. And so then over here we have x squared minus x plus 1. And then we'll keep simplifying, so we'll distribute that 4. So 4x minus 4 equals x squared minus 2x plus 1. And again, this is a quadratic, so I want a 0 on one side. So I have x squared. I'll subtract 4x from both sides, which gives me negative 6x. And then I'll add 4 to both sides, which gives me a positive 5 over here. And because I know you guys like it better, I will put my 0 over here. So then we'll factor the left side. This one factors as x minus 1 times x minus 5. And set each of our factors equal to 0. So x equals 1 and x equals 5. So last step is to check. So remember, this side is non-negative.
So when you have a 0,
That's fine.
technically positive, right?
I mean, it's not positive or negative, but it's not negative. So as long as it's not negative, that's okay. So if I put 1 in for x, is my right side negative? It's not, so that's okay. When I put 5 in for x, is my right side negative? So that one is also okay. So again, both solutions work. Does that make sense what we did with that coefficient? The key is just remembering that you have to square it, right? That you can't just like copy the 2 because it's not under the radical. So that exponent doesn't have anything to cancel it out. So just like on the right side, you actually have to square it. Okay, so I'm going to give you your homework so that you can get started on it before we go, so you can get some practice on this.